Friends, welcome to my channel. Dhanesh here. In this video, I am going to discuss time series forecasting using PyTorch. Time series data, as the name suggests, is a type of data that changes with time. For instance, the temperature in a 24-hour time period, the price of various products in a month, the stock prices of a particular company in a year. These are all examples for time series data. Time series forecasting is an important area in machine learning. It is important because there are so many prediction problems that involve a time component. These problems are neglected because it is this time component that makes time series problem more difficult to handle. What are all the characteristics of time series prediction? What makes a time series different from, say, a regular regression problem? There are two things. The first one is it is time dependent. So the basic assumption of a linear regression model that the observations are independent doesn't hold in this case. The second point, along with an increasing or decreasing trends, most time series have some form of seasonality trends, that is, variation specific to a particular time frame. For example, if you see the sales of a woolen jacket over time, you will invariably find higher sale in winter seasons. RNN and sequential data. See, recurrent neural network is a solution for handling sequential data. See, RNN process historic data. But there are two drawbacks with RNN. One is the vanishing gradient and the second one is the exploding gradient. The solutions for the drawback of RNN are LSTM, long short-term memory, GRU, get at recurrent unit, and the latest one, the BERT. Now, the implementation. See, I am implementing the time series forecasting by using LSTM and PyTorch. Let's get into the implementation part. I am using Anaconda. On top of that, I have all softwares like Python, everything is installed, and I can launch the Jupyter notebook from here. Here I am importing the necessary libraries. I have imported the PyTorch. I have import Torch and Seaborn, NumPy, Pandas, all the libraries I have imported. Let me run this program. You can give a pip install PyTorch. To install PyTorch, you can do this pip install PyTorch. I have run it from the Anaconda terminal. I have done a conda install PyTorch, and I have installed PyTorch in this system. Even printing it. Yeah, you can see it here. This is the data set. The data set that will be using the flights data set. Let's load the data set into our application and see how it looks. So this is the output. You can see it here. The dataset has three columns: year, month, and passengers. The passengers column contains the total number of traveling passengers in the specified month. Let us plot the shape of our dataset. Yeah, it's 144,3. You can see there are 144 rows and 3 columns in the dataset, which means that the dataset contains 12-year traveling record of the passengers. The task is to predict the number of passengers who traveled in the last 12 months based on the first 132 months. Remember that we have a record of 144 months, which means that the data from the first 132 months will be used to train our LSTM model, whereas the model performance will be evaluated using the values from the last 12 months. Let's plot the frequency of the passengers traveling per month. Let's write the script for that. And the next script plots the monthly frequency of the number of passengers. This is showing the monthly frequency of the number of passengers. Fine. This output shows that over the years, the average number of passengers traveling by air increased. The number of passengers traveling within a year fluctuates, which makes sense because during summer or winter vacations, the number of traveling passengers increases compared to the other parts of the year. Next, we will get into the data pre-processing. The types of the columns in our dataset is object, as shown by the following code. I will write that script. Yeah, you can see it here. The first pre-processing step is to change the type of the passengers column to float. It's done. Now if you print the all_data numby array, you should see the following floating type values. Let's print it. Next, we will divide our dataset into training and test sets. The LSTM algorithms will be trained on the training set. The model will then be used to make predictions on the test set. The predictions will be compared with the actual values in the test set to evaluate the performance of the trained model. The first 132 records will be used to train the model, and the last 12 records will be used as a test set. The following script divides the data set into training and test sets. Let's write that script. Now let's now print the length of the test and train sets 12. If you print the test data, you will see it contains last 12 records from the all_data numby array. Now let's print test, and our dataset is not normalized at the moment. The total number of passengers in the initial year is far less compared to the total number of passengers in the last years. It's very important to normalize the data for time series predictions. We will perform min-max scaling on the dataset, which normalizes the data within a certain range of minimum and maximum values. We will be using the min-max scaler class from the sklearn preprocessing module to scale our data for when you learn convolutional neural networks, you do this min-max scaling. So let's do the script for that. It's fine. Now let's print the first 5 and last 5 records of our normalized training data. You could see here. You can see that the dataset values are now between -1 and 1. It's important to mention here that data normalization is only applied on the training data and not on the test data. If normalization is applied on the test data, there is a chance that some information will be leaked from the training set into the test set. The next step is to convert our data set into tensors since PyTorch models are trained using tensors. You are aware of that. PyTorch models are trained using tensors. Tensors means they are containers for data. There are one-dimensional tensors, two-dimensional tensors, three-dimensional tensors. Three-dimensional tensors we call it as matrix, and two-dimensional it is we call it as vectors. You are familiar with that. To convert dataset into tensors, we can simply pass our dataset to the constructor of the float tensor object. Let me write that piece of code. Processing, it's working fine. Now the final pre-processing step is to convert our training data into sequences and corresponding labels. You can use any sequence length, and it depends upon the domain knowledge. However, in our dataset, it is convenient to use a sequence length of 12 since we have monthly data and there are 12 months in a year. If we had daily data, it is a better sequence length would have been 365. That's the number of days in a year. Therefore, we will set the input sequence length for training to 12. Next, we will define a function named create underscore in-out underscore sequences. This function will accept the raw input data and will return the list of tuples. In each tuple, the first element will contain a list of 12 items corresponding to the number of passengers traveling in 12 months. The second tuple element will contain one item, that is the number of passengers in the 12 plus first month. Let me write that function. Now, next script is to, I am executing the following script to create sequences and corresponding labels for training. Here, it's working fine. See, if your print length of the train underscore in-out underscore sequence list, you will see it contains 120 items. This is because though the training set contains 132 elements, the sequence length is 12, which means that the first sequence consists of the first 12 items and the 13th item is the label for the first sequence. In the same way, the second sequence starts from the second item and ends at the 13th item, whereas the 14th item is the label for the second sequence, and so on. Let's now print the first 5 items of the train underscore in-out underscore sequence list and see the output. You can see that each item is a tuple where the first element consists of the 12 items of a sequence and the second tuple element contains the corresponding label. Next, what I'm going to do is creating the LSTM model, long short-term memory. We have processed the data. Now it's the time to train our model. We will define a class LSTM which inherits from NN.module class of the PyTorch library, and so this code I will write the code for the LSTM model. The constructor of the LSTM class accepts 3 parameters: input underscore size, that corresponds to the number of features in the input. Though our sequence length is 12, for each month we have only one value, that is total number of passengers. Therefore, the input size will be 1. The second parameter, it is hidden underscore layer underscore size. That specifies the number of hidden layer along with the number of neurons in each layer. We will have one layer of 100 neurons. The third parameter is output underscore size. The number of items in the output, since we want to predict the number of passengers for 1 month in the future, the output size will be 1. Next, in the constructor, we create variables hidden underscore layer underscore size, LSTM, linear, and hidden underscore cell. LSTM algorithms accepts 3 inputs: previous hidden state, previous cell state, and current input. The hidden underscore cell variable contains the previous hidden and cell state. The LSTM and linear layer variables are used to create the LSTM and linear layers. Inside the forward method, the input underscore sequence is passed as a parameter, which is first passed to the LSTM layer. The output of the LSTM layer is the hidden and cell states at current time step, along with the output. The output from the LSTM layer is passed to the linear layer. The predicted number of passengers is stored in the last item of the predictions list, which is returned to the calling function. The next step is to create an object of the LSTM class, define a loss function and the optimizer. Since we are solving a classification problem, we will use the cross entropy loss. For the optimizer function, we will use the Adam optimizer. Let me do that part, and I have given the learning rate as 0.001. And now let's print our model. Yeah, you can see it. The output, you can see it here. Now we will train the model. We will train our model for 150 epochs. You can try with more epochs if you want. The loss will be printed after every 25 epochs. Let me do that piece of code. Run this and I will show you the output. Yeah, it's since our test set contains the passenger data for the last 12 months and our model is trained to make predictions using a sequence length of 12, we will first filter the last 12 values from the training set. We need to write the code for that. I will do the script for that. Let me run this. See, you can see the output here. You can compare the above values with the last 12 values of the train underscore data underscore normalized data list. Initially, the test underscore inputs item will contain 12 items. Inside a for loop, these 12 items will be used to make predictions about the first item for the test set, that is the item number 133. The predict value will then be appended to the test underscore inputs list. During the second iteration, again the last 12 items will be used as input and a new prediction will be made, which will then be appended to the test underscore inputs list again. The for loop will execute for 12 times since there are 12 elements in the test set. At the end of the loop, the test underscore inputs list will contain 24 items. The last 12 items will be predicted value for the test set. I will write the script for that for loop. You can print the length of the test underscore inputs list. You will see it contains 24 items. The last 12 predicted items can be printed. I will write the script for that. I will see it here. See the output, you can see it here. It's it's important to mention again that you may get different values depending upon the weights used for training the LSTM. Since we normalize the data set for training, the predicted values are also normalized. We need to convert the normalized predicted values into actual predicted values. We can do so by passing the normalized values to the inverse underscore transform method of the min-max scalar object that we need to normalize our data set. Let me do that. You can see the output here. It's here. Let's now predict the values against the actual value. Above, we create a list that contains numeric values for the last 12 months. The first month has an index value of 0. Therefore, the last month will be at index 143. The next script, I will plot the total number of passengers for 144 months along with the predicted number of passengers for the last 12 months. Yeah, you can see it here. See, this is the output, month versus passenger, and the predictions made by our long short-term memory LSTM are predicted by the orange line. You can see the orange line. You can see that our algorithm is not too accurate, but still it has been able to capture upward for total number of passengers traveling in the last 12 months along with occasional fluctuations. You can try with a greater number of epochs with a higher number of neurons in the LSTM layer to see if you can get better performance. To have a better view of the output, we can plot the actual and predicted number of passengers for the last 12 months. I will show you. Let me run this script and see the output. Yeah, it's coming here. You can see the output here. Yeah, this is the output, month versus passenger. Here we have plotted against total passengers. The predictions are not very accurate here as well, but the algorithm was able to capture the trend that number of passengers in the future months should be higher than the previous months with occasional fluctuations. So that's all here about time series forecasting. Thanks for watching. Please like, share and subscribe. Thanks a lot.